You can create a list here of floats and say, let me just call it list. And it's an array list, of course. And in this list, we add a float value, maybe 4.2f, then another float value of 3.1f, and perhaps, so imagine this is, maybe you're measuring the speed of something that's moving through some distance. So there's some instances where the speed will be the same. It will accelerate and decelerate and come back to the same speed. So you might have values that are repeating. So you might end up with 3.1 again. And maybe the object whose speed you're measuring might return back to 4.2. That's an acceleration. Might accelerate again to 4.2. And then it might okay, let me leave it there. So here we started at a very high speed, decelerates to 3.1, maintains 3.1, and then increases to 4.2. So one thing you can see with these values is that they are duplicating. There are instances where they are the same. And array list allows this behavior, so that you can write programs like that that measure the performance of F1 drivers, for example. And here, if we print out our list, and make it culturally relevant. So this is speeds. So we are in some F1 track, and we are measuring the performance of the drivers, and this is how the speeds are going. So if we print the speeds here, I remember array list comes with an inbuilt toString, so we don't need to do extra work. Yeah, and we get the speeds here. So it starts with 4.2, moves to 3.1, 3.1, 4.2. So you can see we can duplicate. We can have the same value repeated. Now, what if we want to know when was the last time they were at 3.1, for instance? So we know they were at 3.1. When was the last time they were at 3.1? So with that, you can use lastIndexOf. So lastIndexOf checks for the last time a value appears in the array list. And we can do that here, since I hope you guys are used to the inlining things, so I don't have to create additional variable. So last occurrence, too many is, last occurrence of 3.1, because we know 3.1, that speed duplicates. So last occurrence of 3.1 is, and we can come here and say speeds dot lastIndexOf 3.1. So just like because it's expecting floats, so just like the contains function, lastIndexOf accepts an object. It accepts one of the elements. Of course, it will go in, first thing it will check whether it's contained. I'm assuming it will check whether it's contained, because why you look for an index of something that is not even in the array list. And then now it will check for which indexes it appears in. In our case, we know it appears in, this is index 1, because this is 0. This is index 1, and the other index here is index 2, and this other index is index 3. So 3.1 appears in 1 and 2. So let's see what lastIndexOf will give us. So you'll see last occurrence of 3.1 is 2. So this is the last time we got 3.1. So when was the last time we got 4.2? 4.2. So we'll just do the same thing here, and we are looking for 4.2. And if we run it, we get last occurrence of 4.2 is 3, which is this index. So it doesn't give you 0, so it gives you 3. So that's the what you can achieve with lastIndexOf. Might seem like a small thing, but if you don't know that this API exists, what usually happens is you'll find developers crafting very complicated algorithms to do things that are already built into the language. So you'll find somebody here writing they'll write a for loop, and then they'll iterate over the values, they'll compare them and track the indexes, and when they find the index, they see whether index is greater than the last index. So all of that is already done for you inside the language, so you don't have to write complex algorithms to achieve that. So that's the importance of knowing some of these available API functions. So that's what you can achieve with lastIndexOf. Let's just like the other one, let's see what happens if we pass in a speed that they didn't reach. Maybe they're looking for 11.3, and we know they did get to 11.3. Let's see what the API will do. So if I run that, we see it does the same behavior with indexOf, in that if you check for a value that doesn't exist, you get a -1. And even if we go to, okay, so this is the list interface. So if we go to array list, which I have here, java.util.arraylist, and if we look for lastIndexOf, so we'll find this function. So this is the function we are calling, and of course it's calling some other internal functions. So I think they're using that because it has a cuter name, and there's some arguments that are hidden within the API. So it will call this, and what this essentially does is, of course, it will check for null, and then it does this loop. So if you didn't know this API exists, you'd actually be the one writing this code, unfortunately. So you might be trying to replicate this for no reason. Of course, it will. We have a for loop here, which means it's going to loop through all the elements. Check if I think this probably checks whether we've reached the end or something, and then if 0 is null, if the object is null, of course, because it can process nulls, there'll be a different algorithm for that. If they are not null, there'll be a different algorithm, and this algorithm checks whether the values are equal at the particular index, and then it return that index. So this is the index that we are being given. So if it goes through all of these and none of these return functions are called, we get to this point where we return -1. So internally, this is essentially what's happening. And if you are a big fan of algorithms and data structures, it's fun to go into these collections and look at, for example, these implementations. It might also be a chance for you to see whether you could write it better.